Today we are going to solve these three numericals. These numericals are from the third chapter of FSC first year physics. The name of the chapter is Motion and Forces. This is numerical number 5, this is numerical number 6, and this is numerical number 7. We will solve them one by one. Numerical number 5 is a proton is moving with a speed of 1.0 times 10 power 7 meter per second. So the initial velocity of the proton is given as 1.0 multiplied 10 power 7 meter per second. When the proton passes through a 0.020 centimeter thick sheet of paper, let's consider this as thick sheet of paper, and the thickness of this sheet is 0.020 centimeter. When the proton passes through this sheet, then a decrease occurs in the velocity of the proton, and the velocity change from 1.0 times 10 power 7 to 2.0 times 10 power 6 meter per second. So the final velocity of the proton is 2.0 times 10 power 6 meter per second. Thickness of the paper is S is equal to 0.020 centimeter. So this will be the distance the proton will cover. So we are going to calculate the acceleration, which is actually the deceleration, which the velocity of the proton decrease. So this will be deceleration, and the time taken by the proton to cover this 0.020 centimeter displacement. We will use third equation of motion for the calculation of acceleration, and the third equation of motion is 2as is equal to vf square minus vi square. In this equation, this A is acceleration, S is the displacement, Vf is the final velocity, and Vi is the initial velocity. Solving this equation for acceleration, we will have A is equal to Vf square minus Vi square divided by 2S. This 0.020 centimeter is equal to 2.0 times 10 power minus 4 meters. This is just converted from centimeters to meters. For converting this to meters, just shift this dot from here to this 2.0. This will become 2.0 times 10 power minus 2, and centimeter is equal to 10 power minus 2. So we will have 2.0 times 10 power minus 4 meters. Now substitute the values for initial velocity, final velocity, and the displacement in this equation. We will have A is equal to 2.0 times 10 power 6 whole square. This 10 power 6, this is the value of the final velocity. This is the value of the initial velocity, and this is the value of the displacement, but we have converted the centimeter to meters. Now solving this equation, take square on this term and on this term and multiply these two with this term. We will have this new term. Further solving this, we will have to adjust the power of these both, 10 power 12, and this will also become 10 power 12, so that we can subtract this term minus 100 times 10 power 12 from this 4.0 times 10 power 12. So subtracting this minus 100 from 4, we will have minus 96 times 10 power 12 divided by 4 times 10 power minus 4. Now further solving and simplifying, we will have acceleration A is equal to minus 2.4 times 10 power 17 meter per second. And this is the value of the acceleration, or the value of the deceleration. The negative sign means that the proton velocity decreased. The final velocity of the proton is less than the initial velocity. Now for calculating the time taken by the proton to cover that small distance, we will use the first equation of motion. The first equation of motion is Vf is equal to Vi plus At. We have calculated the value of acceleration as A is equal to minus 2.4 times 10 power 17 meter per second. Now substituting the value for the final velocity initial velocity and acceleration, we can easily determine the value of time. Solving this equation for time, we will have this at is equal to Vf minus Vi, and dividing both the sides by a, we will have time t is equal to Vf minus Vi divided by a. Now substituting the value for final velocity, initial velocity and acceleration and solving, we will get the value of the time taken by the proton to pass through this thick sheet is equal to 3.33 multiplied 10 power minus 11 seconds. These are the steps involved in solving this equation. This is 2.0 times 10 power 6 and this is minus 1 times 10 power 7. So for subtracting these two terms from each other, you will have to adjust the power of 10. For adjusting the power of 10, this is 2.0 multiplied 10 power 6. So we will have minus 10. This dot is shifted from here to here. So we will have to subtract 1 from this 7. So we will have minus 10 times 10 power 6. Now subtracting this, we will have minus 8 multiplied 10 power 6 divided by minus 2.4 times 10 power 17. This minus will cancel out with this minus, and we will get the value of time t is equal to 3.33 times 10 power minus 11 second. So this is the time taken by the proton to pass through this thick sheet of paper. This is numerical number 3.6. Statement of numerical is a constant force F change the speed of an 80 kg sprinter from 3 meter per second to 4 meter per second. The initial velocity or the initial speed is 3 meter per second. The final speed is Vf, which is 4 meter per second, and the time taken during which the speed changed from Vi to Vf is 0.5 seconds. Calculate the acceleration for the sprinter. So we are going to calculate the acceleration for the sprinter. For calculating the acceleration of the sprinter, we just use the simple first equation of motion, which is Vf is equal to Vi plus At. Solving this again for A, we will have At is equal to Vf minus Vi. Dividing both sides by T, we will have A is equal to Vf minus Vi divided by T. Now substituting the values for final velocity, initial velocity and time t, we will have 4 minus 3 divided by 0.5. 4 minus 3 is equal to 1 and this 0.5 is 5 by 10. So we will have 10 by 5. Dividing this 10 by 5, we will have 2 meter per second square. You can even do this easily with calculator. But this is also correct answer. So we will have acceleration A is equal to 2 meter per second, and this is the required answer. We have calculated the acceleration of the sprinter and the acceleration is 2 meter per second square. This is numerical number 7, and the statement of this numerical is a 4 kilogram ball traveling with the speed of 2 meter per second. We have this ball and this ball is traveling with a speed of 2.0 meter per second. Mass of the ball is given as 4 kilogram. Mass of the ball is given as 4 kilogram. This ball strike the wall and rebound elastically. This ball strike the wall and rebound elastically. Elastically mean there is energy is conserved in elastic collision. So this is an elastic collision, and the energy before the collision will be equal to the energy after the collision. If the ball is in contact with the wall for 0.050 seconds, this is the time. What is the momentum imparted to the wall? We will calculate the momentum imparted by this ball to this wall and the average force which is exerted on the wall by this ball. So for calculating the momentum imparted to the wall, first we are going to calculate the initial momentum. The initial momentum is denoted by P1, and we know that momentum is P is equal to mv. So the initial momentum of the ball is P is equal to mv. M is mass of the ball and V is velocity of the ball. Mass of the ball is given as 4 kilogram and velocity of the ball is 2.0 meter per second. So multiplying 4 with 2, we will have 8 kilogram meter per second. And this is the momentum of the ball, or the initial momentum of the ball. After rebounding from this wall, the momentum will be equal to minus 8 kilogram meter per second. This is Newton's third law of action and reaction. This wall exerted the same force on the ball, and the ball is rebounded from the wall, but that difference is only the direction. So the first initial momentum of the ball is 8 kilogram meter per second, and the final momentum will be equal to minus 8 kilogram meter per second, which is opposite in the direction of the initial momentum. So there is only just the change in the momentum of the ball, change in the direction of the momentum of the ball. So the change in the total change in the momentum, which is del P, will be equal to P2 minus P1, which is initial momentum minus final momentum. The initial momentum we have calculated is minus 8, and the initial momentum we have calculated is 8, and the final momentum is minus 8. So minus 8 minus into 8, we will have minus 16 kilogram meter per second, and this is the change in the momentum. Now the momentum imparted to the wall will be equal to minus change in the momentum, because this change is the momentum is caused by the wall. So the momentum imparted to the wall will be equal to minus into del P. Substituting the value for del P, we will have minus into minus 16, which is equal to 16 kilogram meter per second. So this is the momentum imparted to the wall by the ball. Now we will calculate the average force exerted on the wall. For average force exerted on the wall, we will use Newton's second law in term of momentum. We know that the Newton's second law is F is equal to the force. F is equal to mass time acceleration, and acceleration we know is equal to V divided by T. So we have mv divided by T, and mv is momentum. So del P, change in the momentum divided by time, is Newton's second law. I have used this negative sign because the average force exerted on the wall is opposite to the force on the ball. For this we will have this minus del P divided by T. Now for this reason, substituting the value of change in the momentum we have calculated was minus 16 divided by 5.0 times 10 power minus 2. This is the time taken. This is the time which is given as 0.050 seconds. In scientific notation form, this time can be expressed as 5.0 times 10 power minus 2. So this is the value of the time. Now further solving, this minus sign will cancel with this minus sign, and we will have 16 divided by 5 10 power 2, which is equal to 3.2 times 10 power 2, and further solving we will have 320 Newton. And this 320 Newton is the force, the average force exerted on the wall by the ball. That's it. Thank you for watching, and don't forget to subscribe easyedu for more videos. Thank you.